Morning, guys. So, I'm the first guy up. So I get to talk to you guys a little bit about what we've been working on for the past 3 years. I work on Windows. I work in the WinRT team, or the Windows Runtime team. My team was the team that built the kind of foundations for all of the APIs, and really for the applications that you all are going to be building on top of the platform. So I get to kind of kick this event off by kind of talking about a few interesting aspects of our platform. I'm going to go and spend some time building an app for you on stage so you guys get a bit of a feel for what it's like to do that. And then the rest of the presenters throughout the day are going to kind of fill in more of the kind of details and stuff around the topics I'm going to introduce you to up front. So without further ado, I thought I would warm up the crowd. I like warming up the crowd by showing people pictures, because that always gets their attention. And I want you guys to cheer, right? This is audience participation kind of thing. I'm going to show you pictures. If you like whatever the picture is, you can cheer for it. If you don't, you can stay silent. We're going to start off with some easy things, which is food. Okay, huh? Bacon. Oh, a little bit more. Yeah. And, hey, this is another food group. There we go. Okay. Now, here the next set of pictures I want to show you are pictures of people, right? These people happen to have created some programming languages. So, cheer for, whatever your affiliation or allegiances lie. So let's start with this guy. Silence. That's Alan Cooper. Okay, there we go. There's a few in the room. How about this guy? Brendan Ike? A little bit of love for Brendan, okay. How about this guy? Oh, a little bit more love for Bjarne, huh? And then, of course, there's this guy. All right. So, with that out of the way, I thought I would just kind of, just bring up the agenda. We're going to spend a bit of time up front just talking about this platform, what it means, what are the different kind of pieces of it, and I'll try and frame what this platform really means to you technically. So I'm going to spend a bunch of time there. We're going to take a look at the APIs that are available, and this is not like I'm going to read a list of APIs to you, but rather what I'm going to do is show you some groups of APIs just to give you a feel and a taste for what's available inside of the platform. We're going to spend a bit of time talking about the store as well, just to kind of reinforce some of the concepts that you heard earlier in the introductory video. And then finally, we're going to go off and build this app. And that's going to be the kind of fun part. We won't be in PowerPoint. We'll write some code. You'll get to see this thing actually run. And the key thing about what we're going to do today is you're going to leave understanding what these investments that we made to the platform, how we've fundamentally kind of changed and reimagined what the app development platform and experience is for you guys so that you can have this great opportunity building apps along with us for Windows 8. So let's talk a little bit about Windows. So the big thing about what we're doing here is we've been talking a lot about this reimagining of Windows. And really what it is we have this touch-first experience inside of the platform. So a lot of what is kind of new and unique and interesting in the Windows 8 apps that we have now is this idea that it's designed for touch first, right? So this design language with these very large clickable tiles that invite people that are kind of live and dynamic and update with fresh content is kind of a key part of the underpinnings of what we've done in this kind of reimagining process. Another thing is that Windows runs on many different form factors. So our OEM partners have certainly gone off and built, tablets type devices, convertible tablets where you can kind of take a tablet, you can snap it into a keyboard, or we can have, things like our Surface where, the keyboard is kind of attached to the cover. So there's lots of really interesting innovation around kind of unique and interesting form factors that are kind of novel for Windows 8. And then there's, of course, the kind of traditional platforms that we have. I run Windows 8 all day long on a desktop with 2 monitors as well. And I also run it on my laptop. So there's lots of different form factors. There's a lot of what we know already today with Windows, as well as a lot of the new stuff around this touch-centric or touch-first experience that we have inside of the user interface. We also have a new way of distributing apps to users. So we have an app store, so users know that they can go to this one place a place that they trust, and they can go and download applications on their machine with confidence, knowing that these applications aren't going to mess up their machine, aren't going to change their configurations. When they say uninstall this application, they have confidence that the app is actually gone. And then finally, we have this new programming model that we're introducing. We're going to spend most of our time today talking about what this programming model is and what it represents for you guys. And I think it's a little bit better if we just kind of go to the next slide here to kind of blow up what that thing looks like so we can see what this platform looks like. So this is an architecture slide, and like all architecture slides, it's a gross oversimplification of what the platform is. But it's illustrative to try and kind of get some key points across. One of the things I like to start up at the top there when we talk about the rendering technology. So we have 3 different rendering technologies that you can choose from if you want to build a Metro-style app that can be downloaded by users through the store. The first is you can use DirectX. So if you're building some kind of high-performance graphics, be it 3D graphics with Direct 3D, or high-performance 2D graphics using or DirectWrite APIs, that's all available through the DirectX rendering surface. If you are building applications and you want to reuse a set of skills that you know from XAML, so you are a WPF developer, you're a Silverlight developer, you can use the XAML experience to allow you to go off and build those applications or to reuse existing components that are out there as well, right? So there's a lot of interesting things that we can have if you are a XAML developer. Or you can choose HTML and CSS as your rendering platform. So HTML, CSS, again, if you're a web developer, those are familiar technologies that you know for how to go off and create applications with kind of flowing text and rich media. So those are the kinds of things that you can think about. You can choose which rendering platform that you want. And after you've kind of, based on what your application does, you know what rendering technology that you want to use. Underneath there's a set of programming languages that support those technologies. So for example, if you're a DirectX programmer, what you'll be using is you'll be using C, C++ to program against the DirectX APIs. If you are a XAML developer, you can use C# or VB, the .NET family of languages, or you can also use C++ to go off and program against the XAML stack as well. And if you are an HTML, CSS developer, of course, the natural language for you to be programming is JavaScript, right? So that's available to you as well. As we're going to see today, we also have the ability to mix and match those languages inside of the same application. So for example, what we'll see today is you can build an application in JavaScript that also has a C# component embedded inside of that as well. And those things will seamlessly talk to each other inside of the application. So this hybrid application model also allows you to do a lot of interesting things. And by allowing you to try, and the reason why we have so much choice here is that it allows you to reuse what you know already today, be it some language skills or some library skills that you've acquired over the years. And it also allows you to use the best technology for the job. Right? So based on what the application that you're doing, go off and do that. And we're going to see a lot of these kind of code reuse opportunities, and I'll give you an example of a code reuse opportunity when we build our application today. And then underlying all of this stuff is, of course, Windows. And what we did on our team for this release was we created this Windows runtime, or this WinRT. The APIs inside of Windows are seamlessly exposed to those programming languages above. So if you are a JavaScript developer, you can call a Windows API from your application and feel like that API was designed for JavaScript. If you're a C# developer, you can call that same API using C# conventions to talk to that API. And if you're a C++ developer, you can do the same thing, right? The key thing is there's only one API. That API is implemented by our teams in Windows. But you, as a programmer, can choose whatever language that you want to talk to that same API. Right? So that's a key investment that we made to make it very easy for you to use the right language and the right tool for the job that you have in mind for the application that you're building. And of course, there's a very rich set of APIs that kind of underlie that. So let's drill in a little bit more there. No, this is the, before we get there, this is the way that we kind of make this happen. So there is only one set of APIs, right? There's a Windows runtime object that was created by various teams inside of Windows. And we'll see some examples of that when we build our application. And those APIs are exposed to your application through this term that you'll hear us talk about, this term called a language projection. And really what this is it's an interop layer, really, right, that makes it very easy for your code to directly talk to those APIs. You don't have to go off and use some kind of wrapper library or anything else, right? You have direct access to the APIs. That direct access is facilitated by a bunch of magic that our team created for you. In conjunction with our language partners, be they the JavaScript team, the C# team, or the C++ team, to make it very straightforward to seamlessly call into these applications. And it's all facilitated by this thing that we call Windows metadata. And that Windows metadata is essentially a machine-readable description of what that API looks like so that the language projections can construct the appropriate, let's call it a proxy, to allow you to go off and talk to the underlying Windows APIs. It's very fast, it's very direct access to the APIs inside of Windows. And again, during the talk today, we'll see examples of what that looks like. If you're wondering about the kinds of APIs that are available to you as well, right, there's a very rich set of APIs. We're going to see today, we'll be introduced to a set of these APIs, but this will just kind of give you a flavor of the kinds of APIs that are available to you inside of the platform. So be it, hey, I want to go talk to my webcam, or I want to go off and play a video. I want to use NFC to connect to another device, or receive a message when somebody taps on my device with another device that's NFC enabled. Right? All of those things and all of those APIs are available to your application. So again, without belaboring the point, there's a bunch of things that you'll discover as you start exploring what the platform is and the capabilities that we have built for you inside of Windows. And then finally, when you're distributing your application, there is the Windows Store. There's a bunch of really kind of interesting there's certainly a lot of developer opportunity things in terms of how you can go off and monetize your application. Lots of different business models are available to you. But one of the really cool things, especially for developers, once you have your app out there in your customers' hands, we've actually made telemetry data available through the Windows Store as well. So if your app, so as we all know, we write bugs. It's just part of what happens, right? So when your application is out there in the wild, there's a class of bugs that only ever show up once your app is deployed to actual customers. And when your app crashes out in the field, we have services and features as part of the platform that will send you back telemetry reports when the application crashes, so you can do some diagnosis and fix the application, right, once you have gathered some data about how things are crashing. This is the same technology that we use in Windows and in Office when applications crash to send us back data, right, so we can improve the product in the next release. Right, so we're going to make a bunch of that technology available to you guys as well. And later on, there's an entire session devoted to the store, so I won't belabor the point at this time. So that's the end of my slides. So let's go off and spend a little bit of time building an app. What I like to do is let's show you the end. Let's go right to the end. Let's run the application that we're going to build, and let's see what it does. So what this thing is this is a HTML editor. There's syntax coloring over there that you can see. There's line numbers, there's some stuff like that. When I hit the magic key, which is Control-Enter, it will take the text that was entered into there, essentially paste it into the HTML, and then just run it, right? So it allows you to go off and preview things. So this is just a video tag that's playing some video inside of a Windows 8 app. So this is the thing that we're going to go off and build today. We have some integration with the operating system. So here's a case where I could type some stuff and hit some stuff, and it goes off and renders a video. I can also bring up an app bar down here. I can click on Open here. I can click on a file that's in my file system on my machine. Click on Open there, and we can go off and hit that, and we can go off and display funny pictures of cats. So there's a lot of really great features that are available to you, and we're going to spend some time inside of this talk kind of building this application out of a bunch of stuff that we found lying around. Now, when we dive into this application, the reason why I wanted to show you the application the way it is that it tells a story, a particular story about being able to integrate a bunch of components together that fits into a half-hour-ish kind of talk. Right? So this is not the only thing you can do when you're building an application. There's lots of other things. You can start by building a XAML application. You can reuse some XAML libraries. But for the purposes of this talk today, we're just going to do some JavaScript. find some existing JavaScript libraries. So for example, that thing on the left-hand side, all that syntax coloring and line numbers and all that stuff, we're not going to write that. We're just going to find an existing library that lies around on the internet. We're going to drag, but effectively just copy it into our application and get it to work. Okay? And I'm going to show you this kind of evolution of how you can start through a set of skills that you may already know. So if you're a web developer, we're going to start by building a web application. We're going to convert it and morph it over time into a Windows 8 app. So let's take a look. All right. Let's come out of here. Let's get a Visual Studio. Let's go to the command prompt. And we're going to start from scratch, right, which is always the best way of starting. So if you were to build an HTML editor, right, it kind of makes sense to build it. So think about what I was telling you about before. You have a choice of what rendering technology to use when you're building an application, right? So since we're building an HTML editor, it probably makes the most sense to go off and build an HTML editor using HTML as the rendering technology, especially since we want to do all of that. This is what the live preview of what that HTML looks like on the side. So let's go off and start by building a simple web application. So this isn't a Windows 8 app. This is just a web page. We're going to start by building a web page, and we're going to turn it into one of these apps. So let's start off by doing that. So here is the simplest possible HTML page that is also a text editor. So here is a text area element inside of the page. And what that is this is where I'm going to type in my text. I'm going to have a little bit of code down here which says, hey, if the user types Control-Enter, let's take whatever the user typed in editor.innerText, and let's inject it into the page in output.innerHTML. And output over here is just simply a div element. Right? So that's the simplest possible thing that we can do if we were trying to go off and build an HTML editor as a web page. All right, so let's go off and start this guy. And if I come up here, hit Control-Enter, we see Hello World. All right, nothing particularly fancy, but this is really the simplest possible thing, and that's a very straightforward HTML editor. We can come back to this thing. We can make it look a little bit fancier. We can inject a little bit of CSS, because this is typically what we do. So perhaps I started off by building the HTML structure there. I handed off to my designer friend. They came back with some CSS that we can inject into the page. I can come back here and refresh this page. And now I have, a little bit more formatting and stuff, right? It looks a little bit closer to the thing that I showed you at the end, right? Now, what about taking it to the next level, right? So now what I would like to do is get that kind of syntax coloring component and inject it into my HTML page. So if we look around on the internet, we can find this library. It's called CodeMirror. CodeMirror is just a JavaScript library with some CSS. Associated with it, which allows you to essentially build editors. So it's an HTML-based editor. It does syntax coloring for all sorts of different programming languages. And as it turns out, if what I want to do is add support for editing HTML in JavaScript in the syntax coloring editor, all I have to do is copy 7 files from the distribution. So let's go off and do that. So I can go off and copy those 7 files. I have 2 directories. There's the CSS directory. There's the 2 CSS files that I need. And there is a JavaScript directory with the 5 JavaScript files that I need. All right, so I can take those files. They're now part of my web page. I'm going to add some references to my code. So let's go back to the page now. And there is the references to the JavaScript files that I'm going to need to use. Oops. And there is some references to the CSS that I'm also going to use there as well. Right? So now I have references to all of those 7 files that came from the CodeMirror distribution. I don't need the text area anymore, because as it turns out, hold on a second. So there is the CSS that I want to add to there as well. Right? So that's just going to make it style out a little bit nicer. And then down here, what I'll have is I'll add the code for the editor. And I can delete this code down here and replace it with some CodeMirror specific initialization code. Right? So as you can see by looking at the code, I'm going to new up a new editor object. I'm going to set a few options to say, hey, I want some line numbers. I want my tab spacing to be 2. And then we're pretty well done. So let's take this thing now and let's run it. Come back to the web. There's my page. I'll hit F5, and now I have this editor. Let's look at cats again. And so there's my dancing cat. So this is an HTML page, which now runs most of what we saw inside of that application. Right? There's, on the left-hand side, I have this syntax coloring editor. On the right-hand side, I have my HTML preview section that's available to me there. Right? And I've integrated some existing third-party code that I found lying around on the internet. Now let's take the same thing and let's turn it into a Windows 8 app. So let's see what we got to do now. So let's start up Visual Studio. And we can now go off and do a file new project for this guy. So we're going to file new project. It's JavaScript. And let's come down here to a blank app. And we're going to go into the demo. We're going to call this this app editor. We'll say OK. And Visual Studio will go off and using the blank app template, go off and generate all the files that I need to for my app. I'll hit F5. And we'll see the app pretty well does nothing, right? It says content goes here, but that's it. This is just the framework and the template that I can use to start adding stuff to my application. So let's kind of do the same set of steps that we had before, right? Let's get back to the same state that we were with just the web page as the app. All right, so let's come over here. Let's open up default.html because that's where all of the stuff lives. Remember, there were 7 files that I needed, right? From the distribution. So let's go off and copy those files. And once I've copied those files, what I need to do is inside of my project, here you'll notice there's a CSS directory here. I need to make sure to add those files to my project. So if I navigate to the CSS directory, you'll notice that I copy those other files in their CodeMirror and Lesser Dark. I'm going to add those guys there. And inside of JavaScript, I'll do exactly the same thing. Right, let's go to the JavaScript directory. Those are the files that I copied. I'm going to add to my project. So now those files are available to my project. Now what I need to do, of course, is add some references to those files as well. So let's go off and do that. So there is, hold on a second. Let's start by doing this. We'll drop this in place of this area. So this is the simplest possible text editor example again, right? So if I came back out to here and we run the application, notice here that this is that simple case here, right? No styling, no fancy editor, none of that stuff. Right, now let's add a little bit of code that allows us to do that. So let's copy this in here. So what we've done here is we've added the references to those 5 JavaScript files. We've added references to the 2 CSS files that provide our styling. And then down here is just a bunch of CSS that makes it look a little bit prettier. Now we are going to do exactly the same changes down here that we did before. So there is my div for the editor. And this initialization code also needs to change. And we're going to add that. Right? So this is exactly the same code that we had with no changes whatsoever from the HTML page that was a web editor or an HTML editor. And now what we've done is we've now added everything to our Metro style app, right? So again, we can go look at the pictures of the cats, and we now have a Metro style application. Not bad, right? That was a pretty straightforward set of things that we had to do to go off and get us to where we are today, right? And because it's an application, we can have the same set of things. I can go off and do the same gestures that I can to go off and close and terminate an application inside of Windows. Now, so what's really kind of going on under the covers? What we have is we started off with just an HTML page. And with that HTML page, it had the editor and the live preview of HTML in there. If we looked at what was running that HTML page, shouldn't be surprising, it was running in Internet Explorer, so it runs inside of iExplorer.exe. Let's take a slightly closer look at how this application runs so you can see conceptually what's happened. When we're now using HTML and CSS as the rendering technology, when you take that code and we run it, it runs inside of a different container. It doesn't run inside of IE. It runs inside of a container that we call affectionately WA-host or dub-a-host. So let's see what that looks like. Let's bring up a handy-dandy tool, Process Explorer. And let's go and rerun my application. So I'm going to run this application again. It's now just sitting here on the screen. And I'll tab back to Process Explorer. Let's search for WA-host. Oh, I've found Whost there. We'll make that go away. And I want to inspect the properties of Whost. And when I inspect the properties of Whost, the thing that I want to call your attention to here is these two things here. We started your application up, right? So you can see the executable for running the application is this whost.exe thing. And you can see that the current working directory for Whost is demo editor bin debug appx. When you are running your applications inside of Visual Studio, what Visual Studio does is it copies a bunch of stuff to that directory. So let me just go grab the path here for a second. Let's go to Explore. Let's paste this guy in. And again, when we kind of take a look at what we have inside of here, those are all of the files inside of your application. There's a CSS directory, there's a JavaScript directory inside of that, which contains all the files. So remember, this is why you had to add those files to your project inside of Visual Studio. So Visual Studio knows, hey, I need to copy these files to this output directory. So literally what happens when you run your application in Visual Studio by hitting F5 is, it says, hey, go look in this directory and go run that default file. All right, that's effectively what Visual Studio is telling Whost to go off and run. Now, when you package up your application for distribution to your customers, obviously we're not going to just point them to a directory. Instead, you're going to go through a process of packaging up your application into a file. That file is called an appx file, and that's the file that you use to upload your application up to the store, and that's the file that your customers are going to get when they download your application from the store. An appx file is really just a zip file with a bunch of stuff inside of it. All right, your application assets plus a little manifest in there, and we'll see some examples of the manifest later on when we kind of start poking around inside of our application. All right, so that's what's going on here. So far, we've kind of taken an application. We've kind of built it up from scratch, but it really doesn't take advantage of Windows at all. It's just an HTML editor, so I can type some stuff in, I can hit my Control-Enter, and it displays some HTML. So let's add some stuff that really kind of sets it apart from being just a plain old web page, effectively, right? That's inside of a new container, and let's integrate it in with the platform. So one of the most obvious things that you can do is let's allow the user to open a file in the file system, right? You know, and that's a really great example of kind of integrating in with the platform. So let's add a little bit of code that allows us to go off and do that. So before we get there, the thing that we need to do is let's add a bit of UI. You remember at the beginning when I showed you the application running, I brought up that bar from the bottom of the screen. Right? That thing is called the app bar, and there was an open button that sat in there. So what we'll do is we're going to go off and create that user interface element so that we're going to add a little bit of, you know, the UI, the Windows 8 UI to your app. So let's see how we can do that. So I'm going to use a slightly different tool from Visual Studio. I'm going to use Blend. So I'm going to right-click on default.html, and we're going to open up that same file inside of Blend this time. And Blend has some really great features for previewing what your application looks like when it's actually running. Right, so when I have this thing go off and fit this thing to the screen, you can see here that what Blend has done is, this is actually a pretty impressive thing, right? My application displays like the line number 1, there's a little gutter there and all the styling, and it's also drawn a frame of what a tablet would look like around the application, right? So it's actually running the application and giving you a kind of a live preview, which allows me to edit the HTML inside of the page, right? So some really, really cool technology here. Now, let's take this app bar thing. So there's a set of assets that I have available to me for my application. I can just go drag and drop an app bar down here. And you can see here that it's also created a little button. It's an example button that sits down there in the corner. So let's go over here and let's edit that button. I'll give it an ID. We'll call it CMD Open. I can change its background or its icon to be an open file thing. And one of the kind of cool things, again, about having a richer UI for editing this stuff is I can see a preview of what the open file icon looks like before I've actually selected it. So I've got open file there, and let's just change the text here to say, hey, let's just open the file. Okay? So I'll save this. My work is done inside of Blend. We'll go back to Visual Studio so I can add the code. And you can see that what it's done down here is added those 3 lines of HTML to my page. Right? So I've got a very rich editing experience. I can edit in code if I want, or I can edit in a designer if that's what I want to do as well. So there's default.html. Let's go off and add the code that we need to do this stuff. So the next thing I want to do is I need to wire up an event handler. So when the user clicks on that button to open the file, I need some code to execute in the page. So let's write a little bit of code to do that. So there we have app.onloaded there. So this is the code that executes when the app has finished loading. And what that one line of code does is, hey, go find the HTML element whose ID is CMD open, and let's bind a function, right, this open file function I haven't defined yet, to its click event handler, right? So very straightforward event-based programming that I'm sure you're all used to. And over here, let's add one more thing. Let's add the actual implementation of OpenFile. So there's a couple of things. This is your kind of first exposure to what we call WinRT APIs. So WinRT APIs are these modern object-oriented APIs that you would expect to have in a platform that launches in 2012. So we have types. Those types are organized in namespaces, right? Those types can have methods, they can have properties, they can have events. Right? So again, the very kind of familiar programming patterns that you've known all along, right, really continue to live on inside of WinRT. And you can see what we're doing is we're going to call one of these APIs a Windows API directly from JavaScript. So let's take a look at what we have. There's windows.storage.knownfolders.documents libraries. You can go, I'm guessing what this is that documents library thing knows where my documents library is for me as a user. And I'm going to go off and call this function called getFileAsync. And I want to go off and get a reference to the hello.html file that sits in my documents directory. Right? And then after that, I'm going to call something that will just go off and read the text out of that file. So that's using the underlying platform. Now let's run this application and see what happens. We're going to run. I'm going to bring up the app bar. I'm going to say open. I'm going to click on that, and it goes boom. One of the first things that you're going to see here, and this is the kind of interesting thing that I want to point out there. Access is denied. Why? Well, I've got an application. And what's that application trying to do? It's trying to open some random file right inside of my documents directory. Is that a good thing? It depends, right? Sometimes that's a perfectly OK thing for an application to do. Sometimes that's a terrible thing for your application to do. Imagine what you're doing is you're building an MP3 player. Now, an MP3 player would probably need access to your music collection so that it can enumerate all of the files and present you with a fancy UI to allow you to select which song to play. So that's a perfectly usable use case for having that. And you need to declare these kinds of things in your application manifest. So you can say, hey, because I'm an MP3 player, I need to have access to your music collection. You're going to declare that. The user sees that when they download the app from the store. The person who's reviewing the application when the developer onboards the application to the store also gets to see that and says, oh, yeah, it makes sense. He's trying to play music, and it should have access to your music file. But really, should a music player have access to your documents? Should a calculator have access to your documents? So those are the things that start opening up some red flags in which the reviewer is saying, well, I have no idea why a calculator needs to be able to open files in your My Documents, saying, we're going to deny this application. So remember that when you're building your application, you declare explicitly the set of capabilities that your application supports. There's a whole bunch of them, right? But one of them is access My Documents. And so there's definitely this check. The user can apply the check. The person at the store can apply the check. So this allows people to have confidence that they're not going to go off and download some application that's going to take all of their documents and shoot them off to some crazy server in Siberia somewhere, right? So those are the kinds of things that you have to think about as a user, but this is how we gain confidence in the model, right? It's by forcing developers to explicitly state the set of capabilities that they want from the system and to only use the capabilities that make sense. So this is the principle of least privilege. Now, so we come back to this guy. There's a couple of kind of cool things inside of Visual Studio. I really want to point out this little blue link here. It says, stop debugging and add documents library access capability to manifest. This is kind of the equivalent of, please make the error go away, right? But again, make sure that it makes sense for your application. In this case, remember what I'm saying is, it's not that the application gets kind of like when you're declaring this capability, it says your app can programmatically access files in your documents directory. But the user can always navigate in to your documents directory and pick the file that they want the app to open. That doesn't require this capability. This essentially says, I can do a dir of your directory and see what's inside of it, okay? We don't need that for this application, so we're not going to turn that on. All right, so let's break. Let's get out of here. Let's get rid of this code, because we're not going to use this code anymore. And I'm just going to add a couple lines of code here to actually implement this file. And what this code does here is it uses a Windows service called a file picker to go off and present some UI to the user, system-provided UI, where the user can navigate around and pick the file that they want to go off and open. Okay? Now, let's just see this thing running first, and we'll come back and we'll take a closer look at the code, because there's some interesting patterns inside of the code that I just added. So again, if I go off here, I can click on Open now. I can see now that I can click on this Hello page, and I can see a different Hello World thing. So there's a file I just opened, pulled it out of the file system, right, and I can go off and run and execute it. So let's take a look at how that function works, because you'll notice that there's just a bunch of interesting things that you may or may not have kind of picked up. One of the first things that you'll tend to do is you'll kind of create these aliases for things so that you don't have to type things that are super wide, right? So that's all those 3 lines of code do, is it just defines some aliases to make it easier to kind of parse the code that you're looking at here. The interesting thing is here. So let's start off by looking at the code. I'm going to create one of these file open picker objects. And then what I'm going to do is I'm going to say, hey, let's start in the user's documents library when it comes up. And I want you to just filter down to just files that end in a .htm extension. And then I'm going to say, hey, picker, go off and pick me a file. And you'll notice that the name of the API we're calling is pick single file async. And async is something you're going to see over and over and over again inside of WinRT APIs. What async says is, go off and call this function, and then what happens is that function returns immediately, right? So what I'm actually doing inside of here is, I'm going to say, OK, call this pick file async, and then by the way, when you are done, call the code that's right here. Now this is a JavaScript thing. We'll see later on how we're going to be able to use async APIs from C# as well. And when you're in C#, you won't be using this kind of promises style model from JavaScript, but instead in C# you'll just be using the await keyword. So a lot of the ways that we've kind of introduced for you to create or do asynchronous programming in the platform in the kind of natural and familiar way that you would expect using the language that you're using. So what this says is, when the user is actually finished picking the file, go off and execute the code here. And you'll notice that this function, this anonymous function or this lambda in JavaScript, gets called. The operating system will pass it a file object. I can then use that file object to go off and call another API in Windows in WinRT, which is the fileio.readTextAsync API, which of course is, OK, I don't go read the text. When I'm done reading the text, I'm going to call this next hunk of code inside of here, where the contents, or the actual HTML, the text that was read out of the file, is passed back to me inside of this function. And I'll just go do some stuff to kind of set it inside of my editor. That's how it works. You'll see async programming everywhere. The reason why we want you to do asynchronous programming is that in this case, when we're calling this code, we're calling it on the user interface thread. Right? So if your user interface thread goes off and does something, it could be something as innocuous as opening a file. But what if the file was on a file share, or it was some machine that's intermittently connecting or disconnecting? When that happens, the user is going to be staring at a spinning donut, right, if we were doing this as asynchronous call. Right? But as an asynchronous call, your UI remains responsive, and then you get called back when the data or when the operation is actually complete. You don't block the UI thread. We've spent a lot of time talking about fast and fluid applications inside of Windows 8. We made a very conscious and very deliberate decision when we designed our APIs in Windows 8 to make any API that took longer than 50 milliseconds or could take longer than 50 milliseconds to complete, we made those things async. Right? So this is slightly more work for you guys as developers, but in return, users get a much better experience from apps that don't show the spinning donut while they're waiting. Okay? So one more thing that I want to show you here is, so we've seen how we can go off and integrate and add some file open capabilities. The next thing I want to show you is how I can take some code that already exists. So remember, one of the themes of this talk is I can go off and assemble and build my application out of code that is currently lying around. And as it turns out, sometimes there's code lying around inside of the .NET libraries that I want to use as well. So the next piece of capability I want to add to my app is, let's make it so that it can open a zip file directly. Right? And as it turns out, there's some APIs inside of .NET that allows me to go off and manipulate zip files. So let me show you how you can gain access to those APIs. Now remember, these are .NET APIs, not WinRT APIs. So because they're .NET APIs, I need to go off and create a little component that simply wraps and delegates calls to the underlying .NET APIs. So let's add a new project. In this case here, this is going to be a C# Metro style Windows runtime component. Let's call it zip. It's going to go off and add. Here's the default code that it created for me. And oops, let's type in a little bit of. This is the zip code that I need here. So this is just what is it? 51 lines of C# code that allows us to go off and delegate the calls to the zip archive API here. And the zip archive API is a .NET API. I've made this thing a Windows runtime component, and I'm going to call this guy from my JavaScript code. So let's see how we can make it do that. So you can imagine, I have another project here. This is going to be compiling into what we call a WinMD file. I need to add a reference from my editor project to this other project. So it's just a project reference in Visual Studio. So I'm going to reference the zip project from my editor project. I'll say, OK, so I now have a reference to this guy. And let's come back over here. And let's replace the open file code that we had before with a slightly updated version of it. And this code here understands zip files in this case. So let's run this again just to make sure we understand what this thing does, and we'll come back again. We'll take a look at the code. So if we run the app now, you notice that these are very familiar kind of Visual Studio conventions that you're already used to. I'm going to click on Open here. And notice here that there's my zip file. You can see that it's a zip file because you can see the little zip thing in the directory there. And let's click on Open here, and that opens my file. All right, so I've now opened the zip file, and the same app continues to run as it did before. So let's come back here and let's see how this works. And I always like trying to understand code that looks like this through the lens of a debugger. So let's set some breakpoints in this thing so I can show you, how we can do this. So the interesting thing is, if the user selected a file that ends in .zip, for example, as we see here, right, this code inside of here is going to execute. And what I'm going to do is I'm going to set a breakpoint here, which is before we call my read first file API that I implemented in C#. And I'm going to set another breakpoint in here, which is, hey, after that API is finished executing, that code executes inside of there, right, to kind of copy the text into the page. And then what I would like to do is let's go off and just start this guy running. So I've got this debugger now attached to this thing. Now what I'm also going to do is something that may be a little bit unexpected to you. Because remember, I have two different runtimes. Right? I've got the .NET runtime, I've got a JavaScript runtime loaded inside of the thing. So I've got a debugger attached to the JavaScript runtime right now, right, as my app is running. What I'd like to do is also attach another debugger to the .NET runtime so I can debug the .NET code as well on the other side. So let's go off and do that. I'm going to create another instance of Visual Studio. Start that guy up. And inside of here, I'm going to open up the same project, and that's the same project there. Yes. And let's go off and go to class1.cs inside of this project. And I'm going to set a breakpoint here. Right, so this is that read first file that is called from over here, right? So the read first file is the API call there, okay? And now what I'm going to do is I'm going to go off and attach my debugger to this thing, right? So remember this thing was called WAHost? right? You'll notice here inside of this dialog that I'm going to attach. You could have multiple WA hosts running at the same time because I could have more than one app running. So Visual Studio will also identify the name of the application as well. In this case, this is the editor app that we have. So I'm going to attach this guy. I'm going to make sure that I select the right debugger. This is, by default, a script debugger. I want to use a managed debugger here. So I'm going to use the .NET debugger. And I'm going to attach it to the process. OK, so now we're attached. Now let's go off and trigger our debugger. So let's go click on Open. I'm going to open the zip file. Remember, I should now land inside of my debugger. Right? So there I am right here. So I'm sitting on this line of code here, inside of read first file here. I can see some information about the file object here. Oops. So there's that thing there. So I have file, and there's .done. If I hit F5 at this point, check out what happens. I'm now sitting in that other instance of Visual Studio. And I'm sitting inside of the C# code now. And inside of here, this is just debugging C# as you would expect. I'm going to go off and open the stream, use a zip archive, go off and open the first file that I find inside of the zip file, in this case, copy it back to a string, right, come back out here, and return it back out to the caller. And if I look inside of HTML here, that's the HTML string that was read from the file. We'll continue, and we'll see that the file sits in there as well. So we actually have this nice kind of debugging experience that we have available to us inside of the tools as well. So hopefully this gives you a bit of a taste for the kinds of things that you can do, right? I kind of started off with a story about saying, hey, let's build this HTML editor using a bunch of stuff that we have lying around. Right, so we certainly used a couple of things. We used that CodeMirror library that we had lying around. And we also used the zip archive library that exists inside of .NET. We kind of combined them together to kind of build a pretty rich thing fairly quickly using the tools that we have available inside of Visual Studio. And the other kind of cool thing that we did was we kind of started with something we knew how to build. So we had our, hey, we're a web developer hat on. So I knew how to go off and build a web editor. And then you saw that it was a pretty straightforward process to take that web editor that I built as an HTML page and turn it into one of these Windows 8 apps on the other side. Right? I just did file new project and essentially just copied all the stuff into this app, and I was up and running. I was able to build an application that had 2 different technologies inside of it. Right? I had JavaScript for most of my UI stuff, but I also had a C# component that happen to just talk to a library, but certainly you can do other things, like reuse existing C# code that you've already written for some applications that you have already. And so there's a lot of power inside of this platform because you have this ability to use the right tool, use the right language, use the right frameworks, use the right libraries to complete the task that you want to complete inside of your application. So that's the kind of cool thing, and some of the things I wanted you guys to take home with you. So let's go back to the slides, kind of wrap up a little bit here. So we kind of look at some of the kind of key investments that we had here. WinRT is a big bet. This is really us reimagining what the Windows APIs look like. I think we did a pretty good job. We have the ability to call the same set of APIs from all of the languages that I hope you guys would be interested in using, right? Be it JavaScript, be it a .NET language, or be it a native language in C++. There's also a bunch of really cool new features inside of C++ in the C++OX language, which we internally call high-level C++, that makes it much easier for you to go off and program against these Metro-style APIs from C++ code that you might have today. There's a new user experience that goes along with it. So a lot of the things that we have, and you'll see much more of the user experience later on today in the follow-up sessions inside of today's talk. We have this new app execution environment. We saw some elements of that app execution environment. We saw how, hey, your application actually runs inside of this tightly controlled sandbox on the machine. Remember how when we tried to access that file inside of your documents library, we got it denied? There's actually a bunch of really interesting stuff that we put into the system to make it so that we could actually deny access. As it turns out, when you're trying to open a file, your code never directly opens the file inside of the file system. Instead, we actually broker it to a separate trusted process that the operating system manages. And that's the process that tries to open the file. If that process is successful based on your capabilities and a bunch of other checks that are being done, great. It's going to hand back to the program. Here is a handle to that file. You can go off and use it. Otherwise, it's going to deny you, and that's the kind of experience that you saw as well. Right? So that's part of the new execution environment. Another thing to remember is part of these new form factors is these things are running on tablets, which are fundamentally or primarily running on battery power. So there's a lot of things that we've also put into the platform that you'll see later on today around how to optimize your applications to maximize the battery life of the user's machine. So there's all sorts of things that happen. So for example, how many people here have done some phone development before? Right, so you guys are certainly aware of this, right? When the app goes off the screen, your app is suspended. And when your app is suspended, it may never come back. Right, so you have to be prepared for this. So there's a bunch of events, and you'll see some examples out later today as well, where you need to handle certain suspending and resuming events. So you will squirrel away and save any user data away, knowing full well that you might never come back. Right, so there's a bunch of kind of key things that we talk about when we think about how the life cycle of your application is managed as well. And then finally, the way we get these things up to your customers is through the Windows Store. Now, there's a bunch of interesting requirements that happen as well. So, and especially in the context of people using existing code. There's a tool that we have that's part of the product. We affectionately call it the WAC. Right, the Windows Application Certification Kit, I think is its actual name. But what the WAC does is it analyzes that AppX package that you're about to upload to the store. It's a bunch of static analysis tools. What it does is it looks at the APIs you're trying to call. Right? It says, are you calling the whitelisted set of APIs that you are allowed to call? Because remember, this is just Windows. So, if you were a C++ developer, you can go off and call any random API that you want. But there's only a subset of those APIs that are actually available to you as a Metro-style developer, building these apps. So because of that, always run your WAC against your app, especially if you're using third-party code that you found lying around, because that code may not work. Like, it may run perfectly fine locally on your machine, but the minute you try and upload to the store will deny you. A good example of this is SQLite. So SQLite, if you go look at SQLite, it's a lightweight embedded database. And SQLite originally could not compile against what we will call the Windows 8 profile. Right? So this is a set of APIs that are allowed for your app. What the SQLite guys did was they made about 1,000 changes to their code base. So it took them about a day to make these, so they're mostly mechanical changes to their code base. It took them about a day to do this, and they were able to get a version of SQLite that compiles just fine. You can go off and download that version of SQLite if you want to use it in your app. But the key thing is the original SQLite, if you ran it through the WAC tool, denied. Right? But if you take the SQLite that had been modified to compile against the correct set of APIs and use the correct set of APIs that we want you to use, it's going to work just fine. Make sense? So there's a bunch of cool things that we'll see here. So with that said, I think I'm done for today. I think there's a bunch of other cool talks that are going to be coming after that. While the next presenter comes up here to set up, I'm happy to take about 5 minutes to answer whatever questions that you guys might have. Questions? Must have some questions. Yes?
So for the debugger thing which you showed, if you don't attach the second debugger to Wawa thing, and if you press F11 at that first breakpoint, where it would land?
So the question was, if I only had the JavaScript debugger attached and I didn't attach the .NET debugger, I was sitting at that first breakpoint and I hit F11, what happens? What happens is you'll go to the next line of JavaScript code.
It will not go to, it will not jump.
No. That turns out to be a really hard problem, as it turns out. So the question was I attaching the debugger to the same process?
No. You attach the debugger to the process of the C#.
Absolutely. That's what we did in the talk. So I attached 2 debuggers.
Without OpenStack on the Visual Studio.
No. That's the limitation for today. As it turns out, to properly implement that feature is really, really hard. Right? So we have 2 existing debuggers. They work fine. Right? So it's a little bit clunky, but at least you can get your job done. Right? Like, you can attach 2 debuggers to the process, and it works just fine. Yeah. Question over there.
So I was under the impression that if you say new Metro-style app, pretty much the APIs that are available to you will be available to install your app in the store. That you said you have to also have WAC. But is that pretty much?
Yeah, so the question was about these APIs that I can build my app on. If you just use Visual Studio out of the box, and you built it using .NET, let's say, and there's a bunch of APIs in .NET, by default, right, it will just work, right? So you kind of fall into the pit of success. It's only when you kind of start adding random libraries that you didn't control, you don't know how they were built, you have to make sure, you should always run the WAC beforehand, right? Because what you don't want is the experience of, hey, I'm done, I'm gonna upload it to the store, and then the store takes some time to churn on it, and it comes back denied, right? When you could have verified, you could have made sure that you passed that step of store validation before you ever submitted to the store in the first place.
The default reference only to the
That's correct. So default references in any Visual Studio project will just work. Yeah. Question?
Great support for XNA for Windows Phone 7, and I see that that's not supported for a Windows 8 Metro style app. I'm wondering why, and if there's any plans to include that, or if third-party libraries have to be.
Sad thing is, I don't do XNA, and I don't know anything really about XNA outside of, I know very little about XNA, so I have absolutely no idea what the reasons were behind it not being inside of Windows 8. Yeah, sorry. Yes? Sorry, I couldn't quite catch the question. Oh, here he's coming with a mic.
The Windows metadata and the projection for the various languages that you talked about.
Yes.
Is it available only for the WinRT, or if I am developing any libraries on top of WinRT, can I leverage the same framework?
So I'm trying to parse the question. So if you're so are you asking, can I build a WinRT library myself?
Yeah, something similar, so that I can call seamlessly from any of these languages using the
Yes,
same Windows
absolutely.
metadata.
Yes. So the answer is yes. You can absolutely go off and build your own WinRT libraries, but only in certain languages. Okay. So JavaScript, you can't build a WinRT library. Right? We just didn't have support for that in this version. But in C#, we saw that. Right? I built a WinRT component and called it from JavaScript. Right? So you can absolutely do it in the .NET languages, and you can also do that in C++ as well. 3 more questions. Okay, go.
Thank you.
Sure.
Like if I had to choose a language for developing my components, so is there any performance improvement if I choose C++ versus C# or let's say VB?
Yeah, so the question is, which language is fastest, I think is what you're trying to say,
Yes.
right?
In terms of...
And like a lot of things, your mileage will vary. Like typically, native code is very fast, right? If you're using it right. If you abuse native code and have crappy algorithms, it won't run as fast. So my advice to you is measure, right? Come up with model systems for what it is that you want, measure it, see how well it works, see whether or not manage is fast enough, or whether or not you need to do native, and if you're doing native, that you're doing that properly to get the maximum performance.
So if we have projections, then how does it matter? Like everything has to go through the same process, because SDK, WinRT has projections, and if I develop a component, it has to go through the same thing. So what I'm trying to understand is, if I, let's say, even I am writing an application in C++, which is not going directly to SDK, it has to go through the same process. Like first it has to go to projections, and then is there a way, is there a difference in terms of how a C# components talk to SDK versus how a C++?
So I think what you're asking is, what is the method call overhead for the C# language projection versus the C++ language projection?
Exactly.
The answer is, I haven't measured that, so I don't really know. So this is certainly something you can do yourself, right? You can call a no-op thing in a loop and measure how fast it goes, and yeah. Sorry, I just don't know. Yeah. Question up front? Oh, here comes the mic. Yeah.
Can a Silverlight app run on WinRT?
Can a Silverlight app run on Windows, or what
WinRT,
is
the new the new platform WinRT? Like the Silverlight apps directly port to it, or we don't have any?
So you can. So there's multiple answers to the question. So if you have an existing Silverlight application and you want to run it on the Windows desktop in Windows 8, that's going to work fine.
Yeah.
Right? In the non-ARM builds, I just want to be clear about that. Okay. So in the x86 Intel builds, it's going to work just fine.
Yeah.
If you want to take that application and distribute it through the store or some other things, you'll have to do some small amounts of changes to that. Tim is here in the room somewhere. absolutely talk to Tim Hewer about that. He'll talk. His team spent a bunch of time kind of converting some existing Silverlight applications to XAML, and he can talk all about the small set of changes that you have to do to make that work. Yeah. One more? Yes, way back there. It's right on the SQLite website. So SQLite.org, you'll see it in there. Sorry, yeah.
Not the source for your modified version.
They have a branch somewhere in their thing, so if you enlist in their sources, you can go off and check out that branch. But the sources are definitely there. They're not trying to hide them or anything. Yep. Cool. Okay, well, great. Thank you, everybody. Enjoy the rest of your day.